Hello everyone, welcome to today's lecture. Today we are going to cover two different things. Okay, we are going to start with a new supervised learning method, a new very popular supervised learning method, which is called decision trees. Okay, we can use decision trees for classification, or we can also use decision trees for regression. In particular, we are going to be talking about decision trees for classification. And this is a really nice and a really popular method, and I personally like a lot this method because it's telling you a lot about your data. Okay, you can infer a lot of information, useful information, given of due to the structure of the tree. Okay, and okay, we are going to be seeing this is going to be taking some time. Probably today's lecture is not going to be enough, but I also want to start working with Scikit library. Okay, so and the Scikit library, as I mentioned a couple of weeks before, we are going to be using as a reference library with very popular implementations of multiple machine learning methods. Okay, so now in this pre-recorded lecture, I'm going to quickly introduce the concept of decision trees. Okay, and in the let's say the first 20-25 minutes of the lecture, and then I'm going to provide examples of how to interact with the Scikit library. Okay, and the idea of today's lab is going to be to use this particular library and to start interact with the and build basic machine learning models using Scikit learning. Okay, so let me just so far we have covered two different machine learning approaches in order to build a supervised learning model. We start with naive Bayes, and then we went with the K-nearest neighbor. You need to remember that the K-nearest neighbor is a popular is using the idea of lazy learning. Okay, basically all the learning process, well, the learning process is, we don't need to build a very complex model during a learning phase. Basically all we do is that we collect all the samples, and then at some point then we are going to be all that process, and then when we have examples as they come, then at that point is when we have to check for the neighbors and so on and so forth. And we also we also covered the feature selection problem. Well, it's actually the feature pre-processing problem. It's not only about selecting a good subset of features, it's also identifying pre-processing features. What do we do when we have missing data? What do we do when if we have irrelevant features, and so on and so forth. Okay, so basically this is the key points that we are going to be talking today. And okay, so basically before starting working on decision trees, remember that what we have in a classification problem is that we want to predict a class, okay, a category. Okay, so we are going to have a set of features, and then we have a category. Most of the time we are going to be assuming that we have a binary classification problem, but we can also have a multi-class classification problem. And a very simple example of this, let's say that I'm on a date, okay, I want to bring my partner to a date, and I want to know if we are going to like a particular restaurant. Okay, so what I want to do is that I want to use all my data science skills in order to build a model that is going to tell me if the restaurant that we go is going to be a good restaurant. Okay, so that's going to be my target attribute, the category that we want to predict. Okay, so basically the key point there is if at the end of the day we like the restaurant or we don't like the restaurant. So that's a very popular classification, a very popular way of seeing a classification problem. Okay, and what are going to be the features that we have to take into account? Well, there are multiple features that we have to take into account in order to define if we are going to like the place or we are not going to like the place. For example, one of the features could be that we are going to identify the type of the restaurant. Okay, if we have an Italian restaurant, if we have a Thai restaurant, or if we have an Italian restaurant. Okay, so this is, in this particular example, this is a the type of the restaurant is going to be one of the features. For example, another feature could be the atmosphere. It could be that it's a fancy restaurant. Okay, it could be that it's clean, it's casual, and so on and so forth. That really depends. Okay, for example, that depends on the type of a day that we are going to have, that I'm going to have with my partner. Okay, it could be that if it's a fancy dinner, then probably we are going to be going for a fancy restaurant, and so on and so forth. For example, if it is going to be if it's a very busy place, that's also another we can also see that as another feature. Cost. Okay, I'm only a lecturer here, so I don't have a lot of money. So cost is also, the money is going to be another important factor to take into account. Hungry, it depends. It's also going to be, but we can also see that as a feature. Okay, so all these are going to be examples of features that we have to take into account when we are building the model. Okay, and the idea is that we're going to be using all these features in order to build a classification model, and in particular we're going to focus in a binary classification problem. And in this case is we have a restaurant, and then we're going to decide if we go into the restaurant because we are going to like the restaurant, or if I'm not going to the restaurant because we are not going to like the restaurant. And the key point here is that we are going to be using these decision trees. Okay, and why is this called decision trees? It's a very simple. It's because the structure of the model that we are going to have at the end is going to look like, the shape of the model is going to look like a tree. Okay, we are going to start at this point, and then we are going to go down in the tree, and at the end we are going to take the decision if we go or if we don't go into the restaurant because we are going to like the restaurant, or we are not going to like the restaurant. Okay, so this is, and trees is the tree data structure is extremely popular in computer science. Okay, it's quite popular. And basically, okay, so basically what we're going to have is that inside all these nodes we're going to have the features, and depending on the value of the feature we are going to follow that path in the tree. Okay, so basically what we do is that we take this feature, and depending on the value we go one direction or we go the other direction. The direction that we go are all the possible values for this particular feature. Okay, hungry, we are going to say that this is going to be a binary feature, so we are going to go one way or the other one, and then we are going to explore a second feature, and then we keep going until we go to the end, and these are going to we're going to call this the leaf nodes, and these leaf nodes are going to be the decisions that we take at the end. Okay, let's see, these are going to be so each particular node here is going to be an attribute or a feature. In this case we are going to be, for example, starting with the feature indicating if I'm hungry or if I'm not hungry. And for example, in this particular case we have that if we go in this direction, it means that we are hungry, and in this other direction means that we are not. And basically we keep going until now. What we are going to be doing is, depending on the direction that we take, we just explore another feature. And again, these are going to be the values. We are going to here explore the values of that particular feature. Okay, so basically here we can say that for this particular feature, if we go in this direction means that we are hungry, and if we go in this other direction means that we are not hungry, and so on and so forth. Okay, so basically, for example, if we decided that at that particular time we are hungry, then we have to evaluate the next feature, and we have to evaluate, for example, in this case, the model that we have indicates that that is going to be raining. Okay, so that we have to check the rain attribute. Again, we can assume that this is going to be binary problem. It's raining or it is not raining, and then we go one direction or the other direction. For example, if we come here, we arrive in this particular example, we arrive to a leaf node, and at this point we are going to have a decision, And in this particular case, we are going to say that go means that we go inside the restaurant because we are going to like the restaurant. Okay, and at this point we can provide a prediction. Okay, so basically this is going to be my prediction because we took this particular path in the tree, and so on and so forth. Okay, something important here from decision trees is that in order to make my prediction, in order to complete my prediction, sometimes I'm not going to need all my features. Okay, in this particular example, we only need hungry and rain for making the decision. We don't need all the features. And as you can see here, for example, and this is also another important property of decision trees, is that the feature that we are going to have at the early in the tree, this is called the root, close to the root. Most likely those features are going to be quite important for the problem. Okay, and this is why I personally like this particular supervised machine learning model, because we can get a lot of information based on exploiting this tree structure. Okay, let me just continue. Now all these guys are going to be the output of my model, if you like, indicating if, in this case, a positive example, for example, indicating that I will go into a restaurant because I'm going to like the restaurant, or I'm not going to a restaurant because I'm not going to the restaurant. So what about if we go into the, in this case, for that particular date, let's say that I go another date, so next week I go to another restaurant, and I want to also use this particular model. That particular date, I was not hungry. So in this case, what I want to check is the type of the restaurant. Okay. Now I want to see if the restaurant is Italian. Let's say in this particular example, we have three types of the restaurants. One is going to be Italian restaurant, and then the other one is Thai restaurant and French restaurant. In this case, for example, we explored the Italian restaurant, and we found that this restaurant and then we identified that this is not an Italian restaurant, and so on and so forth. Okay, and here we have to, this is an Italian restaurant, and here we have to explore another feature. For example, we can say that this feature, we can imagine that this feature is, for example, is expensive. Okay, if this is not expensive, then I'm not going to that restaurant, and probably if this is expensive, then we go into this restaurant. Okay, so don't forget that here we also have the another feature that we have to evaluate. This is just an example of how this particular example looks like, or we can just finish here the decision. Okay, so this is just an example. Let's assume that now we have another model. Okay, this is going to be another model that we have based on previous. We built this model based on previous of a given data set, and then we are going to be seeing how we can classify these particular examples. Okay, later on we are going to be talking about how we can build this model. Okay, so that's something important. Okay, so basically we want to classify this as positive, or I'm going into the restaurant, or negative, or I'm not going into the restaurant. Basically this is how we want to classify all these examples. Okay, so basically for the first one, we have to start looking. Now I'm going to focus only on this particular example, and then we go with the other ones. In this particular case, we go that at the top in the root node. This is the root node. Remember, this is the root node. This is called an internal node, and this one here is called a leaf node. Okay, in this case, we have the value of occupied is true. So basically it means that we come in this direction, and then now we have to look into the type of the restaurant, and this, I think this is a French restaurant. Okay, based on the pictures that we have here. Okay, so this is, I know that was Italian restaurant. Okay, so basically this is an Italian restaurant, and in this particular example is a no-go. Okay, so basically we are not going to like this particular restaurant. Okay, again, a couple of important things. So we don't need to use all the features because we already made a decision. based on that in particular information that we have already. Okay, now we go with the second one. Okay, for the second one, we have that this is going to be false. So all we needed to know at this point is that occupied is false in order to decide that this is going to be a negative example and that we are not going into this particular restaurant. And then for the other one, we have, for example, that this is true. Okay, so basically if this is true, then we go with type. Always we are going to go with the type of the restaurant. In this case, I think this is Thai restaurant. So this is a Thai restaurant, so we decide to go, okay? Because we took this particular path. This one here is false, okay? So basically if this one is false, directly we go with no go. And this one here, it means that this is true. This is, I think, this is French restaurant. Okay, in this case it's a French restaurant. And then we have to look into happiness, okay? It's true, so basically we go. Okay, so basically the last one, let's look into this one. This means that it's true. This is a French restaurant, and now we have two options. And in this particular case, we say that we are happy at that particular point of the day. So this is true. So basically we are going into the restaurant. Okay, so basically this is the general idea of a decision tree. We are going to build the model. We are going to be seeing how to build the model, and then we just have to follow the tree structure. Okay, basically each particular node is going to be a feature, and depending on the values that we have, then we're going to do we follow the path in the feature in the tree. We are not sometimes we are not it might be the cases that it might be some cases that we have to use all the features, but we don't have to use all the features. Once we have enough information in order to complete a decision, we are going to ignore the other parts of the features for that particular example. Okay, and this is going to be my machine learning model. Something important here is that decision trees are sometimes a little bit less sensible to irrelevant features, okay, because the model is going to be ignoring all the features. Sometimes it's going to be, or an important number of times, is going to try to ignore irrelevant features at the point of building the tree. Okay, as you can, sometimes we are not going to be using all the features in the tree model. Okay, that's up to the model, but you have to be careful. Sometimes, if you are going to look into if you look in some websites in the internet, you have to be careful how you read those things, because some people say that this is not that we don't need to perform feature selection for decision trees, and that's not really true. You can also benefit from using feature selection with decision trees. Okay, even though this is in some cases is less sensitive to irrelevant features, also using feature selections is also is going to be a little bit more important. It's going to improve the model if you use feature selection. Okay, so basically this is we have to build a tree. Okay, and what we're going to be doing is that we're going to be using the idea of we have the training data set, and then based on that training data set, we are going to be building the tree. Okay, we are going to be building that model, which the model is going to be a tree. It's going to have this particular tree data structure. Okay, so that's at the end of the day, based on that particular model, we are going to get into this particular structure of the tree. Okay, the key point here, and this is just a very informal way of describing the model. Okay, during the Microsoft Teams lecture, I'm going to go into more concrete details about building the model, okay, and different heuristic approaches in order to build the model. What we want to do at the very beginning is that we have to decide which one is going to be the best. So we have all the features. We need to identify the best feature in order to put that in the root of the tree. Okay, so we take the best feature that is going to provide the best way in order to split the data, because remember that we are going to split the data depending on different things. And then we took that one, and then we asked the question in order to go in order to visit one children or the other children or the other children, as many children as we have. So basically, for example, in this case, we can come that direction or we can come this direction. For example, if we come in this direction, probably we get to a point that all the examples in the feature, it could be the case, okay, I'm not saying that this is always the case, that all the examples are going to be from that particular label. So we have enough information in order to provide an estimation, in order to provide an output for the classification model. So basically what we do, and then for example, if we ask the question, basically in order to continue, basically we define the best feature, we ask the question, and then now we have to identify another feature. Okay, we follow the path and then we go back. Now we are going to select. Okay, so now we are going to repeat this process. Okay, now we have to select again the best feature. Basically, the best feature here. In this case, we are going to select the best feature, and then we are going to check all the possible outcomes. Well, the different outcomes for this particular feature in order to continue building the process. We'll continue the process of building the tree. Okay, in this particular case, we said that we finish. Okay, this is a decision, this is a decision, and here we repeat the process again. We are going to select the best feature, and so on and so forth. And this is a heuristic approach because once we made a decision, okay, this is going to be the feature that we are going to be using at this point of the tree, then we don't explore other values for that feature. If we fix that, then we continue, we fix this one, and so on and so forth. Okay, I'm going to provide concrete examples, I'm going to provide concrete examples, and I'm going to present different ways and very powerful ways in order to build the tree. Okay, we have to look into different properties of the data in order to continue with that. Okay, and basically, as I was saying before, the idea of today's lecture is that it goes to just quickly introduce the concept of decision trees. Now please continue with the more practical part of this pre-recorded lecture, which is a little bit of a tutorial, if you like, of using scikit-learn. I strongly recommend that you reproduce the examples that I'm providing, because during the lab of today's lab, we are going to be using that library for a popular data set, which is the Titanic data set. Okay, please continue with the second part of this pre-recorded lecture.